All right, guys, so today, last section we'll do this week, 3.3, function notation. All right? So again, we're still dealing with functions, but today we're going to do a little bit more. Today we're going to actually do some actual arithmetic with the functions. All right? All right. So from previous lessons, we know that a linear function can be written in what form? What form are we looking for when we write a linear function? Let me give you a hint.
Y equals mx plus b.
Right, y equals mx plus b. Because when I graph that, what am I going to get? When I graph y equals mx plus b, right? I start at the y-intercept. I go where the slope tells me to do. What's it going to look like on the graph? I don't know.
It's going to be a line.
Yeah, it's going to be a straight line, right? Again, linear means a straight line, right? That's why it works. So another notation we can use to write a function is called function notation. All right? So that's one way we can write it. Today, we're going to write it another way. We're going to write it in function notation. Again, basically, it's going to be something in this formula that's going to mean the same thing, just be written differently. That's all. All right? All right? So this is function notation. So I don't know if on your notes you want to draw an arrow down, but this little fx in parentheses equals mx plus b. This means pretty much, and you'll see in a second, this right here means the same as y equals mx plus b. I'm going to explain that to you guys in a second. This is just function notation. All right? It's just a different way to write y equals mx plus b, but it means the same exact thing. All right? All right, so if I was going to name this function, all right, the name we gave to this function is function f, because it starts with the letter f. You can put any letter here in terms of the number outside the x in parentheses. You can put any number there you want. You can put a, you can write m, you can write z. It doesn't matter. All right. So whatever that number is. To the left of the letter, whatever letter that is, to the left of the letter that's in parentheses, that'll be the name of the function. In this case, it's f. Most often you're going to see f, guys, but again, you can use any letter you want there. All right? All right. So like we just said, f of, in parentheses, means the function of whatever letter is in the parentheses. So pronounced f of, this would be, if I was going to pronounce this, it would be f of x. If there was a g on the outside, it would be g of x. If there was an m, it would be m of x.
And you don't say times. I know when you see parentheses, a lot of times you think, oh, parentheses means times. This is a little different.
Yeah. Again, this doesn't, like Ms. Hager makes a good point. That doesn't mean multiplication. It's just a way to name the function. All right? We just want you guys to understand again what that looks like and what that sounds like. But again, we're not going to say, okay, tomorrow on the test, okay, we'll write this down and say name the function. You're not going to have to do that. Again, it's just some background information so you guys have an understanding of how the naming works. All right? So if I look at, like I told you, the formula we've been working with, y equals mx plus b, and I look at the function we're going to be using today, the only thing that changed was the y became f of x, or the y could become g of x. So the y became the letter, whatever letter, with an x in parentheses. Like Mr. Hager said, it doesn't mean multiplication. Yusuf?
Is fx like kind of easier than mx?
It means the same thing, basically. It's the same way. It means the same thing. Some people will write it this way. You'll see it this way sometimes, but it means the same exact thing. The f of x, or whatever letter you have of x, means the same thing as y. If I graph this, it's still going to give me a straight line. It's just written as, they call that function notation, but it means the same exact thing. All right? Guys, we talked a little bit about, at the beginning of the year, about evaluate. Does anyone remember what that means? We have to, the directions in a problem say evaluate. Does anybody remember what it means? Garrett?
Solve.
Okay. How are we going to solve them?
I don't know.
Yusuf?
Would you like go through like the steps to solve the problem?
So I've had something like that, and the direction said, I had a problem like that, and the direction said to evaluate. Miguel? Yeah, I'm going to plug in the value that it gives me for the variable it says it equals. That's what evaluate means. So definition of evaluate, plug in the number given for the variable. Again, if you want to put this example, you can, you don't have to. So it's going to say whatever it equals, right, whatever, again, in this case, x was 2. All we're going to do is plug in that number. All right, we're going to be doing some of that today. All right, so we just it's going to tell us, again, so the work's already done for us. Usually we have to go through and solve and figure out what x is, right? Here, the work's done for us. It tells us, we just plug it in, and there it is. All right, so again, big thing with this, function notation means the same thing as y equals mx plus b. If you graph it, you're going to get a straight line. All right, people okay with this?
Yeah.
All right. So, again, evaluate f of x, again, it means y equals 4 equals negative 4x plus 7. It's given me 3 different values for x. It's giving me negative 3, it's giving me 0, and it's giving me 2. 3 different values. So what that means is, I'm going to have 3 separate problems. All right, what's my first problem going to be? How's it going to be written? Yusuf?
Negative 4.
Yeah?
And then put 3 in the parentheses.
Yeah, negative 3, right?
Yeah, negative 3.
Yeah.
And then plus 7.
Plus 7. That's my first one right there. All right, so a negative 4 times a negative 3 is going to give me what? Positive 12. Good, Yusuf. I'm going to bring down my plus 7 because I didn't use it. 12 plus 7? 19. So you see over here, guys, if I was going to, remember what we talked about in the warm-ups? If I was going to read this, right, how would I read that? What does that say? Ellie?
Would it be like f of negative 3
Exactly.
equals 19?
Exactly. Ellie just did it. F of negative 3 equals 19. So basically what that means is, when you plug in negative 3 for x, you get 19. That's what f of negative 3 is. When you plug in negative 3 for x in the function that it gives us, you get 19. So f of negative 3 is 19. When you plug it in, that's the number you get. All right?
We have like a problem like that on the test.
Yeah. So that's my first one. That's my first. This is like, there's like 3 problems within this one big problem, right? That's one of the 3. What's the second one? Allie?
Would it be like negative 4 times 0
Yeah.
plus 7?
Plus 7, right? See, that's what it's telling me to plug in for the second one. All right. So negative 4 times 0?
0.
0 plus 7. Where do I write this? Where do I write my answer? Allie?
F of 0 equals 7.
Again, when I plug in 0 for x, I get 7. All right? And then my last problem, whatever problem is going to be what? How about Jake? So I plugged in negative 3 for x. I plugged in 0 for x.
I got present too.
So what's my problem? How am I going to write that out? Tell me what to write.
Negative 4
Yeah?
times 2.
Okay. Yeah? So I did negative 4, my x was 2,
Plus 2.
plus what?
Plus 2.
Plus what?
2. 7.
Alright. Alright, so negative 4 times 2. What do I get? Negative 8. Negative 8 plus 7. Negative 1. I'm going to go over here. I'm just going to write it next to f of negative 2. So I'm sorry, 2. When I plug in 2 for x, that's what I get. So that's all you're doing here, guys, is taking the x's and plugging them in. If they give you 3 numbers for x, you got to solve 3 different for that number, right? Each time for that number. So you have like 3 different problems to figure out what each value is. Right? That's all you have to do, is plug in. That's why we talked about evaluating, because you have to plug them in. Okay, to move on? Everybody's got this?
Yes.
Alright, so now, so this one is something for you guys, because again, what we do next is going to be a little different. It's almost like solving an equation. So remember, steps to solve an equation. If there's distributive property, make sure you do that first. Remember, you're multiplying with the distributive property. Combine like terms. If you have any, add or subtract, meaning you want to get the variable by itself. So whatever's on that side with the variable, you want to move using the opposite operation. Then at the end, again, if it's like 6x equals 42, divide by 6. Because again, you want to get the variable by itself. All right? So, this one. Before, it said like x equals negative 2, 0, and I'm thinking, it gave us that, right? And we were plugging in for x. What is it giving us now to plug in for? Is it just x? No, what is it, Chris?
H.
Not h, well, n.
On our paper it says H.
Is it h?
Yeah, on paper it says H.
Oh, okay. So let's change this to easy enough. Alright. So this h, so on your thing, you're gonna write h4 h of x equals, so you already have this written there. You just have to write in the 2x plus 2, and then h of x equals 4. So before, it was just x equals 3 numbers. But now it's not x anymore. What is it telling us? What is it giving us the value of? What value is it giving us? Before, it gave us 3 values for x. What is it giving us the value of now? H of x. Remember what we said, right? I can do a of x, c of x, m of x. All those things mean the same as what? In the original equation that we talked about today. No? No? Math. Yes. All these things still mean y equals. Alright, so keep that in mind. So what is it giving us a value for right now? Is it just x? No, it's h of x, right? So where in my problem do I see h of x? At the beginning, right? So wherever that h of x is, what's going to happen? Allie?
We're gonna put in like h of negative 2.
No. Again, I just said, I'm just showing you before that's what it gave us. Now it's only giving us one value. So where that h of x is, what's going to happen? Matt? We're going to evaluate, meaning that h of x, what's going to happen to it? What's it going to become? 4. So I know there's 2, this is where some people get stuck. I know there's 2 letters there, but it's telling us that that whole thing is becoming 4. I know there's 2 letters there, but it's telling us that that h of x equals 4. The whole thing, I know there's 2 letters, but the whole thing becomes 4.
So like h of x and then like disappears, so it
Yeah, exactly, as we did before. Before, the x disappeared, and the one we did before this, the x disappeared and became those three different numbers that we used. So my problem's going to be 4 equals 2x plus 2. I'm plugging in, again, this number for h of x. Again, it's the same as writing y equals 4. It means the same thing. So there's my equation. Because before, when I get those 3 different numbers, right, I can just plug in for x and I get the answer, right? I didn't have to move anything around because both numbers were on the same side. All the numbers were on the same side. I can just combine like terms. Here I can't because I have a variable and a number or an integer. So we go back, right? We don't have any distributive property. We don't have any like terms. So what am I going to do first? This one only has 2 steps. What am I going to do first? Haley? Subtract the 2 from both sides, right? Minus 2, minus 2. 4 minus 2, 2. Again, I didn't use that 2x, so I just brought it down. One more step. What's the last step, Brady? This means multiply. So I want to get rid of multiplication. Divide. By what number, Brady? 2. Cancels out. Leaves me with x equals 2 divided by 2 is what, Brady? 1. So now, this is like the opposite. When I plug in for what it equals, when I plug in for h of x, right, which was 4, I get 1. That's just the opposite way. Now you're plugging in for what it equals. Right? Before, we plugged in on the right-hand side, we did the arithmetic, and we got the numbers. Alright? So that's two ways you'll see it. We might give you 3 different values, plug those values in for x. We may give you the value that it equals, so again, you almost solve it like an equation. Alright? Now, we're going to graph a linear function by creating a table. Again, we get into like slope-intercept form, like chapter 4 kind of stuff. We can just say, okay, we're going to start at the y-intercept. We want to go where the slope tells us to. In the case of this is the way we want to do it. All right, because we haven't got to that point yet. So we're going to pick 5 different x values to create our table. Kind of like when we do a word problem, right? But again, it usually tells us, okay, we can't spend more than this, or we can't exceed this amount. Or, again, if it's continuous, do like 3 or 4 values to see. When we're graphing, right, for our x's, we always want to use these numbers. We always want to use -2, -1, 0, 1, 2. So when we ask you to graph, right, a linear function, these are the numbers you always want to use. You don't have to make up your own. Those are the ones you always use. Don't get confused with doing a word problem. You don't want to use the negative. When you do the word problems, you don't want to use negative numbers. All right? So we're not going to measure anything in negative numbers anyway. So don't use negative numbers for the word problems. But when we're graphing, we want to use these values. Why would those be good values to use? Anybody think they might know why those would be good values to use? Yusuf?
They're easy.
Yeah, they're small numbers, right? They're easy to work with. And also, you got a mix. You got a couple negatives, a couple positives, and you also have 0. So again, that's why we use those values. Because again, if we have to multiply or anything, we're going to know how to, calculate those numbers. All right? So whatever we get for a function, just like we did for this. All right? But the only thing is, we're going to have -2, -1, 0, 1, 2. I'd plug, that was the function I had to graph. I'd plug in -2, I do it. I plug in -1, do it. I'd plug in 0 and do it, I'd plug in 1 and do it, I'd plug in 2 and do it. So you did something similar to this, just with different numbers. But it's the same exact idea. Plug it in for x. Alright, oh, you guys gotta get this down, right? So, once we set up our table, alright, we'll have all our x values. We're gonna we'll plug in each x value into the formula. In the formula, you were given to find f of x. So we're gonna plug in x, wherever it is in the formula. Just x. If it's f, we're not plugging in -2 here for the f of x. We're only plugging it into where it is after the equal sign. This doesn't matter because it means the same as y equals. So we're not plugging in there, we're only plugging in where it's next to a number. Alright? And then last, right, so when we plug in the number, alright, we'll solve, our answers will go here, and then our coordinates, so the first column and the third column, just like we did when we graphed stuff yesterday, I'm going to go in that last column. So like all these numbers will be my x's. All these numbers will be my y's. And then we'll graph all the points and we'll draw our line. Now when we have all those points, are we going to connect them? Will we connect the dots for this? We're graphing a line, right? Are we going to connect the dots? Yeah. Again, if we're talking discrete and continuous, so we're gonna connect the dots for this. Everybody with me? Okay. Can I move on from this? Everybody's good? All right. So, first thing, what numbers? We just talked about this. What numbers am I going to use for my x value? Matt?
-2, -1.
-2, -1, 0, 1, 2. Again, if we're graphing a linear function, those are the numbers we always want to use. Alright? What I'm going to do here, guys, is I'm going to take my function, which is this. I'm going to write it down here. I'm going to write in -1/2 x plus 5. How am I going to write out my first problem? What am I going to write? I'm going to have x is -2, right? So what am I going to write? Ellie?
Would we do like f of -2 equals?
Again, you can do that. At this point, I'm not really worried about this.
Okay.
All I'm going to write in is all I'm writing in is the function. All I'm going to write here is what comes after the equal sign.
So it'd be like -1/2, like parentheses,
Yeah.
-2
Yeah.
equals 5.
Yep. That's it. Again, all we're doing here is taking all these numbers and plugging them in where I see x. Again, this f of x, you could write in -2 there, but I think having that, because it means the same as y equals, so having like f of -2 equals -1/2 -2. I think this may screw you up. So, in the top of this column, I would just write in whatever comes after the equal sign. Then you're not dealing with that number in there twice. Alright, my next one would be -1/2, -1 plus 5, -1/2, 0 plus 5, -1/2, 1 plus 5, 1/2, 2. All I did was take these x values and plug them in where I saw x in the function. That's all I did. I haven't solved anything yet. All I did was just set them all up. I just took where I saw where I saw x in the problem, and I just plugged it in. Now I'm going to do the math. Alright? So if I have -1/2 times -2. Again, I'm going to do this over 1. All right? I got a negative times a negative, so what happens? It's going to be a positive. Everything here basically cancels out. That's what I get for an answer.
What?
Just 1, a positive 1. This is a negative times a negative. There's my answer, 1. Negative 1/2 times a negative 1. Again, it's a negative times a negative. I'm sorry, negative times a negative, so I'm going to get a positive. Negative 1, I'm going to get 1/2. Because again, all I'm doing now is multiplying the top times the top, the bottom times the bottom. 1 times 1 is 1. 2 times 1 is 2. It's 1 over 2. And you guys just told me it's a negative times a negative, so the result is a positive. All right? 1/2 times 0. 0, right? 0 plus 5? 5. Again, all I'm doing is simplifying the arithmetic that's here. 1/2 times 0 is 0, plus 5 is 5. All right, now I got negative 1/2 times 1. Negative times a positive? Negative. And anything multiplied by 1 is just going to be itself, right? So I'm just going to get a negative 1/2. Does that make sense?
Yeah.
But then you have to plus.
Oh, yeah, I screwed up on these, didn't I?
Yeah. You have to plus
I didn't plus 5, did I? Whoops. Let's fix those. Let's fix those. This will be, I'm sorry, guys. That'll be 6. And this will be, we got 5.5. Sorry about that, guys. And this will be 4.5, correct? And then we got negative 1/2 times a positive 2. So a negative times a positive is a negative. I got negative 1/2 times 2. This will cancel out. And I'm going to end up getting a negative 1, right? Plus 5, I do that right? Negative 1/2 times 2. That'll cancel out. I'll get negative 1. So then I got negative 1 plus 5 is what? 4.
I knew something was wrong.
I didn't add the 5 then. I'm sorry about that. Going too fast. What are all my x values?
Negative.
Go ahead, Yusuf.
Negative 2, negative 1, 0.
So, all I'm doing is taking these and writing them over here. Negative 2, negative 1, 0, 1, 2. What's my first, Joe, what's my first f of x or y value? 6. How about Magelli, what's my second f of x or y value? 5.5. Everybody see how this works? I'm taking these and I'm putting them there. So my next one would be 5. My next one would be 4.5. My last one would be 4. And I'm going to put parentheses around them because they're ordered pairs. All right? And we've kind of done stuff, kind of like what we did yesterday with the word problems. All right? Again, we're just plugging in for x. All right? I'm going to go down a little bit. Actually, I'm going to make this a little bit. All right. So I'm going to graph my first coordinate. All right? Negative 2. Am I going to go left or am I going to go right? Left. Which one's the x? Going across or up and down? Across. I'm going to go over 2, over to the left 2 because it's negative, up 6. 1, 2, 3, 4, 5, 6. There's my first coordinate. That's negative 2, 6 right there. Negative 1, 5. Am I going to go left or am I going to go right?
7.5.
Am I going to go left or am I going to go right? Left how many? Left 1, up 5.5. So I'm going to go halfway in between 6 and 5. So like right here. All right? I'm going to go 0, 5. Do I go left or right? Do I go left or right? No, I stay right here on the origin, and I go up 5. 1, 4.5. I'm going to the right now because it's positive. Right 1, up 4.5. 1, 2, 3. I screw that up. That's better. And 1, 2, 3, 4.5. In between both. Now I got 2, 4. Again, right 2 because it's positive. 1, 2, 3, 4. Now, like you guys told me, it's linear, so it's going to be a line. So let's look something like that. And there's your graph. So again, negative. Your x values are always going to be this. Plug them in, get your y's, take all your x's, write them first, take all your y's, write them second, and then just graph it, or your f of x's, whatever you want to call it, and then graph it. Yeah, not too bad. Like I said, we kind of did things like that when we were doing the word problems. All right? Last thing. Word problem. So again, this one is only asking us not to do a whole bunch of numbers, it's just giving us certain things. So the function c of x, that's how we say that, equals 17.5x minus 10 represents the cost in dollars of buying x tickets to a concert with a $10 coupon. So in this problem, what does x represent? Ellie?
It represents tickets.
X is going to be tickets. Number of tickets. So that covers the x. What's the other thing, or the other letter or symbol that we have? Ellie?
Would it be C?
C, how do we say that?
Of X.
C of x. So C of x.
For how many dollars?
Again, that's going to be the total amount, right?
Yeah.
C of x will be cost
Like our answer?
in dollars. Yeah. So if you can plug in however many tickets you want to buy, and when you do that, it'll tell you how much it costs. Or you can do the opposite. We can give you how much it costs, and then you can figure out how many tickets you bought. Ellie?
Question.
Yes.
But if it's 17.5, wouldn't that mean that there's not enough tickets because it's like 17?
No. Basically, someone tell me what that 17.5 represents? Mary? Yeah, that's how much it costs per ticket.
Okay.
The 17.5 means how much it costs per ticket. All right? And again, C of x, F of x, M of x means the same thing as what? Means the same as what? Means the same as y equals, right? So don't get worried about that. So let's set this up now. Now it's telling us we're buying 5 tickets. Can anybody tell me how I'm going to set that problem up? I'll give you a hint. You're going to start with C of x. Okay, again, this is a package deal. All right? It's not giving us the x to plug in here. You could, but I think it's going to screw you up. All right? So start with C of x equals, what am I going to write now? 17.5. Good, Donovan. Keep going.
5 in parentheses.
5 in parentheses. Good. Keep going. One more. A couple more things.
Negative 10.
Minus 10. That's it. It's set up. All I have to do is solve. I just got to figure out which letters represent certain things. All right. So we're going to do 17.5 times 5. $87.50. $87.50
So then
minus 10.
77.
C of x equals, say it out,
77.
$77.50. C of x equals $77.50. What should I put with that $77.50? Money. This is the money side, right? Because we're dealing with money. All right. So there's that. Now, I'll let you guys get caught up on A. Because B, just like we did with example 1. Example 1, it gave us the x's, we plugged them in, we solved, right? Everything was on the same side, we didn't have to move anything around, we could just do the arithmetic. Same thing here. Everything was on the same side, didn't have to move anything, and this gave me my nice answer. In this case, it's giving me 130 now, right? It's giving me the cost. So what is 130 gonna take the place of? Anybody know? What's 130 taking the place of? Again, the 5 took the place of tickets because we knew X represented tickets. Go ahead, Matt.
The 17.5.
No. What is the 130? Because again, now we have $130. What's that taking the place of?
C of X.
The C of X, right? Because look at, we wrote what C of X represents. Cost in dollars. Here's dollars. I'm gonna go up. C of X, like Donovan just taught, it's C of X equals minus 10. There it is. Like Donovan just told us, C of X is becoming 130. Everything else doesn't change. It's not giving us tickets. Tickets was X. It's not giving us that. It's giving us the total amount, which was C of X. Again, 2 steps. What's the first one? 2 steps to solve this equation. What's the first one? Garrett?
Plus X. I mean plus 10.
Plus 10. Plus 10 on both sides. I'm going to get 120 equals 17.5x. Last step. Mary?
120.
Oh yeah, 140, sorry. Going too fast today. 140. There we go. Alright, last step. Last step. Miguel? By?
17.5.
Divide by 17.5. Divide by 17.5. X equal, let's see, 140 divided by 17.5, right? 8. 8 what?
No, here.
8 tickets. 8 tickets. 8 tickets. Yes? Yes. That's it. Alright, that's it. Everybody good?
Yeah.
Alright, so homework, guys, leave that sheet up so you need the back side to do those review problems. The review problems are quick, some of them are like one word answers. So reference sheet, which is up on Google Classroom, I put it up, I want to say yesterday afternoon. What was that? Yesterday morning, I think I put it up actually. And the test review. Alright? Guys, the test review was a couple pages. The only reason being was, again, there's a lot of graphs and stuff we had to fit on there. That's why it's more than 1 page. Like we've said for the last, like our 4th or 5th test, make sure you fill out the reference sheet first before you do the test review. That way you can put the examples on there. Alright? Oh man. First test of 2nd quarter is tomorrow, guys. And again, you're going to get your report cards tomorrow during your period 9 class. And don't forget, you guys aren't going to be in academics again. I remind you this, I told you guys about this at the beginning of the week. You're not going to be in academics again until the end after Thanksgiving break. So you're off from academics for 2 weeks. After tomorrow, we don't see you guys again in this class until Monday, November 26th. So we got a long layoff. Don't worry. It's not going to be any shop. We won't give you guys any homework over that time.
Let's go.
Alright? But again, keep in mind, if you don't finish the test tomorrow for some reason, I think most of you guys will, you probably all will, but just in case you don't, or you're absent for some reason, come see us next week at some point. Either Wednesday, probably, the only day we can stay after next week is Wednesday, because it's half day Tuesday, half day Thursday. or come in the morning, whatever. All right? Cool. So, flip on that backside.